The extensive use of zirconia in orthopedic dentistry is fairly recent, about 20 years ago, and since then, it has become one of the most popular materials. Initially, it was used to make metal-free dental crowns, posts, implants, and other structures. Currently, zirconia is the basis for creation of high-temperature bioceramics that combine metal strength and aesthetics, as well as compatibility of natural tissues. The main material used in zirconia production is mineral zircon, which undergoes complex chemical processing to form zirconia. In order to ensure high strength, stability, and long-term operation of products, it is partially stabilized with yttrium where 2 aluminum oxide is added, which improves the parameters of finished material. For this very reason, zirconia ceramics are widely used in the industries that require both mechanical strength and biocompatibility, in orthopedics, surgery, hearing aids, implantology, and last, but not the least, dentistry. The key stage in producing the zirconia-based ceramics is micropowder production, because the dispersion degree affects the sintering compaction, the structure homogeneity, and, therefore, the strength and reliability of final products. The finer the powder particles, the better they are distributed inside the blank, the greater sintering compaction it has, and the better the performance of finished product is. However, ball, disc, or vibration mills often prove less than adequate at this particular stage. They do not ensure the required fineness, do not allow for uniform distribution by particle size, and, most importantly, grinding is accompanied by high power consumption and wear of structural elements. In view of the above, GlobeCore has developed a technology for zirconia micropowder production with the use of AVSp batching Vortex layer machines. This unit uses the effect of a rotating electromagnetic field to create a vortex layer of ferromagnetic elements inside the reaction chamber. A vortex layer is a dynamic, energy-intense system wherein ferromagnetic bodies, steel cylinders, randomly rotate and interact with the material to be ground. A vortex layer ensures several processes at a time. Mechanical destruction of zirconia particles to a micro and submicro level, disintegration of agglomerates, and surface activation, which further contributes to high-quality sintering of ceramics. This offers as many as several advantages. Firstly, the grinding rate increases several times, which allows achieving the nanoscale dispersion within a few minutes of processing. Secondly, due to a high local temperature and pressure at the points of contact between particles and ferromagnetic elements, the surface of particles is activated, which improves sintering further down the line. Thirdly, the particle size turns out more uniform, as any irregularities may result in microcracks or deformations under load. Other advantages of AVSp machines include combination of compact design and capacity. The machine capacity may reach up to 50 kilograms of finished zirconia micropowder per hour, which is quite sufficient for small-scale production or for research centers specializing in medical materials. Electricity savings due to less power consumption. Depending on the model, the AVSp Vortex layer machines consume at most 9 kilowatts. Noiseless operation, as well as easy maintenance and use. Control for the machines is intuitive and requires no special operator skills. Thus, the GlobeCore technology paves the way for creation of even stronger, more reliable, and aesthetically perfect orthopedic structures based on zirconia micropowders that will serve the patients for decades. And what kind of equipment do you use for zirconia micropowder production? What problems and challenges are you facing in this regard? Please share them in the comments section. More information on the GlobeCore technology and equipment for zirconia micropowder production can be found by following the link in the first comment or visiting our website, www.globecore.com.